Thank you everyone for joining today's webinar. We have with us Mike Igner. Mike has more than 30 years of experience in emerging technologies focused on supporting customers on their concept to production journey. He has delivered consulting services with top tier companies, including PwC and Verizon. He's focused on engaging with companies to leverage new technologies at the intelligent edge. And today's discussion is around the extreme edge of automotive, connected, electric, and autonomous. So with that, I'm going to hand it over to Mike to take us into his presentation.
Okay, cool. Thanks, Brandy. We're doing this live today, so it should be fun. I'm going to go ahead and share out my screen now. Let's hope that comes up, and then we'll be ready to go. And what you're going to notice as we go through this presentation, it's a lot of material. And so I've tried to boil it down into pieces that I think are important. But if there are areas where anybody wants to drill down further, we can do that after the call. We can do that during Q&A, whatever is required. As folks know, I love to talk about this stuff. And I think that edge computing is just a really interesting topic, especially applied to the automotive space. So I'm going to go ahead and jump forward here. So the industry itself is transforming radically. It's going from what I call a gears and grease mode to silicon and bits, really transforming from just mechanical to being very electronic. And it's been going on for quite some time. It's not that it hasn't been happening, it's been happening. But I think you're seeing it really kick into high gear now as we find the requirement to really pull the computers into the vehicles becoming stronger and stronger. The static, isolated tech ecosystems are really a thing of the past. And we are now seeking to gain real-time data insights, which we can act upon as soon as possible to save lives and drive revenue. So it's a dual purpose here that we're looking at. Most of the automotive manufacturers and OEMs are going through this now. They are experiencing what I call a very heavy lift and shift as they seek to transform themselves into software companies. It's a very big challenge. We know that these automotive manufacturers and OEMs have huge software presence already, but they are really transforming everything about their business internally to get there. One of the things that's really pushing this is the software-defined vehicles are coming very quickly. The capabilities that they have within them are critical to this continued electrification push. And I say smart city integration. Over time, we're going to see these vehicles very tightly integrated into the city grids with regard to autonomous motion, with regard to parking, whatever you name it. There's going to be a very, very tight integration. So there's some technology that has to come in place to make that happen. So I'm going to the next one. Right now, we're seeing a real shift in the automotive focus. And these are a few areas. There are lots of different areas where the focus is shifting, but how we generate value is changing. Traditionally, the vehicle OEMs have been thriving on optimizing these operational elements like supply chain and manufacturing and channel distribution. Those are great things, but they happen on the back end, not very visible to the average consumer. And they've done a great job there and squeezed a lot of efficiency out of those processes. And that in turn, puts money back in the bank account. But we have to face the fact that there are new customer expectations. The traditional automotive customer models don't really mesh with these holistic consumer digital experiences that people are used to having now. And there is a steady and consistent march towards hyper-personalization. People want to know that that vehicle is theirs and that it actually does what they want it to do. And it's some modifications of what's there at the base. And I'm going to be checking my questions as I go around here. And yes, I believe slides will be available. I'll ask Brandy on that. I'm sure she can help us. And we will be recording. So thank you for that question. So I believe we're really at the beginning of this curve. Some people would argue that the automotive manufacturers are already, way pushing into innovation and electrification. They're there, but I think it's still very early. When you look out on the road, you don't see every vehicle out there really cutting edge. I mean, 90 to 95% of the vehicles that are out there are traditional models. So I think we're at the very nascent stages of digital innovation. Now, you do see some really, massive upstarts coming, like Tesla and Rivian that just went public. Those companies are starting with innovation and building a vehicle around that innovation. Whereas with the traditional manufacturers, they have to innovate internally and push outwards. So it's a little bit different, but that's what we're seeing. And there are some companies that are severely lagging right now. I won't mention names, but they do need to kick it up a notch if they want to be able to compete in this marketplace. In the automotive space, I do believe, and a lot of these are my opinions and where I see things going, but I believe that product differentiation is required. And you're going to have to really stand out in the marketplace as delivering something different. Just the basic functionality of a vehicle is important, but people want something more than that. They want something that really appeals to their emotions, that fills a functional purpose, that extends into their life, right? And that their life can extend into, and conversely. So I believe that that's going to have to be driven by company culture within these manufacturers, and a culture that really values experimentation. It also needs to support innovation. And you've got to be continually measuring. No longer will measuring once a year when the person buys their vehicle or sometime, a couple of years down the road, no longer is that going to work. You really have to be continually measuring customer satisfaction. And that's possible now. It's going to be very possible with some of the edge computing technology that's coming into play. And I look at customer satisfaction as a mix of performance of the vehicle itself, plus their emotional engagement. Emotional engagement is something that cannot be underestimated. That is what's going to keep the person in your vehicle. It's going to keep the person coming back to your vehicles and really create that very, very sticky customer. I look at it like chewing gum, right? It sticks to the bottom of your shoe and you can't get it off. That's where we want to go with this type of stuff. And that's what the manufacturers are kind of shifting to at this point. So as we're kind of moving here, we're talking a little bit more about the technology. We are approaching what I call the extreme edge. Some people are not using this term. It's a term that I do like to use, and I'll get into it a little bit more as to what I'm talking about there. But the computers in the vehicles are nothing new. We've talked about this. However, the level of sophistication required for these systems is growing exponentially. And because it's growing exponentially, there are frequent revisions that have to be made to the software due to this level of complexity. So yeah, it's getting trickier, but we also have the ability to update that software faster. We have the ability to fix things faster. And so it's driving everything at a very rapid pace. Now, cloud-based computing, you hear about it all the time, and we're hearing it within context of the automotive manufacturers. You see the deals getting inked that, Amazon or Google or somebody is inking some deal with the vehicle manufacturers. However, what we do need to keep in mind is that cloud-based computing has nowhere near the level of latency, which we need low latency in this case, or persistence of connection required to support some of these applications that are coming up in the vehicle space that require critical time-sensitive decisions to be made. And so we're going to see a combination, not discounting cloud. It's certainly going to be out there, and cloud-based applications will extend into the vehicle, but you require something more than that because the connections to the cloud are not going to always be there. An area that I specialize in around is 5G, and we know that 5G coverage will not be ubiquitous in the next 5 years. It's going to take some time for that to happen as the carriers start rolling that stuff out. So the connectivity is not always going to be there. Something to think about. These vehicles are really becoming now self-contained computing environments. Every function that you would think of in a data center is now moving into these vehicles. And they will have an intermittent tether as they go through different areas of connectivity back to those centralized data centers into the data repositories. So there's going to be a connection, obviously. We use it all the time. But anybody that's used something like Google Maps knows If you drive out of range of the signal, now you're stuck with whatever map or wherever you were on that phone, and you might even lose your signal. You could lose GPS, right? So connectivity is intermittent. So what I'm proposing here is that the vehicles themselves have become the edge, what I call the extreme edge. And that's the last mile of compute between the driver and the road versus the cell tower, which is the far edge. And I'll differentiate between the two for everybody. So hopefully everybody's doing okay right now. I'm just checking again to make sure we have no questions. I'm gonna go to the next slide for us. So why do at the end of the day, why do we care about the edge? Well, I'm going to tell you why. First, by defining it. The edge computing assumes a computing model that brings these capabilities closer to the original source of the data. That supports autonomy, the ability for this vehicle to make decisions by itself. It enhances the response times, and that in turn leads to rapid decisioning. So you get a very usable set of computing capability that sits within the vehicle that allows it to make very smart decisions about, hey, I see a deer, let me stop, let me swerve, let me get out of the way, not hit it, that need to be made at very high speed near the vehicle itself. And I'm oversimplifying that. But as we see, there are tons of driver aids coming online. We have intelligent video being put into these vehicles themselves. And they actually have to be acted upon for things to happen, and it needs to happen at speed. So that's really where edge computing is. Far edge is presently implemented as a fixed location to which the cloud computing is extended. So some of these deals that you see being inked, again, with some of the hyperscalers, is where they're taking cloud-based capabilities and pushing it closer to the road, closer to the vehicle, but not into the vehicle itself. That capability traditionally sits at the bottom of a cell tower, or if you're in a factory or something, or in a parking lot, it might be at a Wi-Fi access point. That's what we're looking at, and that's what we consider far edge. Wind River does a lot of work in far edge around 5G vRAN right now, helping companies like Verizon roll out their radio access network. So some interesting stuff happening there, but it's not necessarily the end-all be-all solution here. Extreme edge envisions a fully articulated computing platform. And I'm going to say very likely in motion, right? 90 to 95% of the time in motion, which to me is why I say it makes it extreme, because it has to deal with a number of different situations very, very quickly. And that extreme edge will operate independently where the data is created and consumed, which is locally. That's a very important distinction. Because when we're talking about cloud and taking data and pushing it back to the cloud, making some decisions on it and then pushing it back, again, there's a ton of lag time around that. And things happen very quickly on the road. I have a diagram here, and I won't get into great detail on this, but I'm looking at 3 axes here. We have connection autonomy, which is the ability for a vehicle to operate without being tethered to a connection. The decisioning speed at which the vehicle and its computer systems can make decisions about in conditions that are encountered. And then function integration, the ability to bring in different functionality from the vehicle manufacturer themselves or other vendors. And what we're doing is we're really moving from a centralized compute model to a far edge compute model to the extreme edge compute model. And the auto compute, I think, falls somewhere here on the top left-hand quadrant. It's definitely autonomous. We know that a car can run without being connected. Many are not connected at all. But there will be an evolution towards that extreme edge compute. I don't even see it going the way of far edge compute. It might temporarily, but I do see a direct line occurring here. It's kind of where I'm seeing it right now. So I tend to go back and forth between the technical and the business. That's where I live, somewhere in the middle. And we need to be aware that edge computing is really more than a buzzword. It's not just a buzzword at this point. It's the real need to process and react to data inputs that are critical to safety, security, and function, while also driving monetization. It's something that's very real. It may not be applicable across 70 or 80% of what we're trying to do right now, but it's going to change over time. The use cases themselves around this edge technology are going to evolve, and they're going to evolve very rapidly. And what we're going to see is use cases are going to start touching each other. So for example, 5G vRAN is a use case at the edge where we can actually be serving people out cellular services. That technology is going to move into private 5G. That private 5G is going to move into the vehicle in terms of vehicle to vehicle communication or vehicle to other object communication we call V2X. So these use cases are going to evolve and they're going to merge into each other. And we're going to really see very specific use cases around real-time data and acting on it where it lives immediately. The data itself that we're creating is the gold mine here. Anybody that follows Google or any company that deals in data, Facebook, knows that data can be monetized both directly and indirectly. It's going to happen in the automotive space, probably sooner than later. And we can also take that data and use it to provide a superior and highly engaging experience for the customers. So by opting in, they get a better experience. And by opting in, we are able to take that data and harvest it and use it to generate revenue. So good stuff all around. I think that in this particular space, though, the key to driving edge-related business is going to be really delivering and nurturing a fully articulated partner ecosystem, which is at its core supported by a very reliable edge computing platform. So we'll have a platform, people will engage in that platform, they will deliver different pieces of capability, and everybody will make money at the end of the day and be happy, and the consumer just gets a better experience. So these are some things that you're thinking about. This is by no means complete, but just some idea of where we're going in that space. So I talked a little bit about the edge itself, and I want to talk about attributes of edge. So when we're talking about an intelligent edge, there are certain attributes that we need to be aware of. And I've kind of laid these out here. If you look on the right-hand side, you'll see different types of use cases that are enabled by intelligent edge. I would say that probably 90 to 95% of these are leveraged in the automotive space or could be. Even I would say even additive 3D printing at some point, being able to print off a part that you need to replace something that's there that's broken could be a possibility at some point. So we may at some point embrace all of these use cases. But the four attributes that I'd like to make sure we understand when we're talking about edge are these. The first one is hyperconnectivity. The vehicles must connect internal and external elements across multiple paths of connectivity. And that's going to require advanced management and prioritization. So at the edge, there's going to be a lot of work around that happening as we transition between 5G connections and Wi-Fi connections and Bluetooth and near field and CAN bus or whatever is there within the vehicle. There's a lot of data pathways that have to be managed. So intelligent edge platforms are going to have to manage that. We also know that everything's going to be software defined. At the end of the day, you're going to be running on commercial off-the-shelf hardware, or at a minimum, very generic processors, microprocessors, and sensors and controllers. And they all are going to have some type of software definability in that you will be able to say, I'm going to use this processor to do A, B, and C today, and maybe do A, B, C, and D tomorrow, or completely change the functions and do E, F, G. So software definition is a critical area in the edge space. We also know that machine intelligence is a big area. And I like this term better than AI because I think that AI is a little bit overblown. But we are talking about artificial intelligence in its various forms. And I think that AI is going to be a very dominant topic in automotive. The use cases are numerous. They drive real advances in autonomous movement, safety, maintenance, and as I've mentioned, monetization is just a real key here. Lastly, I want you to remember this, take a note and remember this, don't forget, this environment has to be highly secured. Edge computing is going to have a very large attack surface because it exposes a lot more to the external world through communication, through different interfaces, through different functionalities and apps. So we have to take a very good look at what's going on here, especially in the automotive space, since safety is of concern to us, cybersecurity has to be equally relevant. And I think some companies are actually underestimating this right now. Had several conversations, and there's a lot of interest there because we don't know what we don't know at this point in time. So Making all this work at a functional level means that you have to glue things together. And I like to look at this space between the vehicle, which I'm saying has an extreme edge, and the cloud, where we have a lot of data and we want to take data back to and do things with it. You need to glue it together. And so what you're going to need is what I call a service enablement block. And that is essentially going to connect the inside world to the outside world, to the inside of the vehicle to the outside world, and do it seamlessly across different network transports, putting in things like firewall. In a car, you have a firewall, it's where the term comes from, right? Between the engine and the driver. So you're going to have electronic firewalls as well that will need to be built into these edge computing platforms. There's going to be a wide ranging amount of processor support required. Every day we see new processors coming out. And in addition to these traditional microprocessors, we're starting to see acceleration with GPUs. We're starting to see neural processing units that actually boost the ability to do AI work. There's a lot of stuff coming, but we're going to have to be able to handle that as well, which comes back to the software-defined thing we were talking about a little bit earlier. Applications themselves have been very monolithic in the automotive industry, and they are moving into a virtualized space. They're moving into even further a containerized space. I won't use the buzzwords a lot, but you've heard things like Kubernetes, Docker. These applications are moving into containers, which are nicely isolated and can be orchestrated very easily, stopped, restarted, it can speak with other applications. It's a very well-behaved environment, and I think it's going to see a lot of adoption in the automotive space over time here. We also, again, want to take advantage of commodity hardware where it exists, and the AI piece cannot be underestimated. There's a lot of robotic process automation and machine learning that will occur here. And of course, as we connect everything together, we've got to look at the security options. So here at Wind River, for example, this is a very critical piece for us. And it's a piece that's actually missing with a lot of automotive manufacturers and OEMs right now, because they're missing this gap they're missing this glue that allows them to glue the two worlds together. This is an area where we focus right now. So in this whole, I'm going to go to a little bit different subject right now, but in this whole mix of things happening very, very quickly, we have intelligent feedback loops. That is, we have data that's being created and being acted upon very, very quickly. And if you look at this wonderful graphic with these different little items around it here, what you'll see is that this data can be leveraged to do a lot of really cool things. So for example, let's just say we see some sensor data that shows that somebody's dragging their foot on a pedal, and they're keeping their foot on that brake pedal all the time, and they're wearing down their brake pads. We have an opportunity to see what's happening there, to take some corrective action, ask that person, get your foot off the pedal, you're wearing down your brake pads. And if they've already done the damage, we could actually take them and redirect them to a service center and say, look, you've been dragging your feet on the brake pads, you've worn them down, it's a dangerous situation. We noticed that you had to stop very abruptly a couple of days ago, you almost hit a deer, and we think that you should get those things serviced. That leads to a better experience for the customer. It leads to monetization for the automotive manufacturer and the OEMs. So it's a good deal all around. So you get a real customer satisfaction that comes out of that. And again, you get monetization. If we ask for the user's permission, we can also take that real-time data and harvest it for fine tuning of the automotive components themselves. How are things operating under stress, under pressure? We can use that data for revenue sharing opportunities with partners. And then we can also build in safety enhancements for the customers. So this is a really cool thing. And this can only be accomplished. The reason I'm bringing it up here is that this can really only be accomplished in real time if we leverage edge computing capability in the vehicle, the extreme edge. And so this is something that has to be considered. The scenarios are numerous. There are a lot of stuff going on here. But at the end of the day, you also have the ability to do a lot of monitoring of this environment in real time, take corrective actions, and you can even be testing things in digital twin environments. So conditions that you see occurring all the time, you can actually take it off to a lab, start testing it, and come back with answers and solutions very, very quickly. A lot of neat stuff. The reason I mention it is that you need to be aware of intelligent feedback loops. You will hear about this frequently. In the automotive space, I know we deal with this already, but it's going to get much more intense and much more, I'll say, sophisticated. I'm going to check my questions one more time here. And Ali was asking, talk about more about the layers in the previous slide. I'll come back to that in the question, in the answering question and answers. We can do that for sure. So I'll do that. Okay, let's see here. So we talked about the intelligent feedback loops, and I have this really great eye chart here for you. And I can send, if anybody wants to see a copy of this, I can send you a much bigger one. A lot of my clients take these and print them out and put them on the wall and work across them. This is a mind map of the software-defined vehicle or software-defined transport. And what it really highlights, the reason I'm showing you this eye chart is that it highlights the complexity of the environment we're dealing with. And I would say this is really only first or second level. It's not very intense. I mean, you could take each one of these areas and drill down further and further and further. Where I've drawn the lines, I would say these are the areas we're doing really well with, or we've spent a lot of time in the automotive industry. You know, the sensor technology is there. We know that connectivity has been a big focus, getting the vehicles connected to the users themselves, and then connecting for over-the-air updates. But I think that a lot more is going to happen in that space as the vehicles themselves get connected in as edge devices or as extreme edge platforms into the network. I think there's going to be more changing there. Autonomous movement, I highlight that because we've done a lot of work there at this point in time. All the driver, safety aids and all the work being done right now around autonomous vehicle motion. It's a big deal, but I don't think we've touched on it yet. And when I look at this, I would say, and you all might have different opinion, but I'm thinking we're only 20 to 30% addressing these supported tools and platforms at this point, because there's just so much more to do in that space. But I want to give you, like I said, I want to give you an idea of what's here. It's a lot. It's just a lot. And so as this complexity grows, we need to build development environments internally that can handle this. And I'll talk about that in just a second. Again, if anybody wants to see this, take it and I'll send it to you. You can blow it up, make it big and look at it, and work against it. So that leads us, you saw that maybe we're 20 to 30% addressing it. I think that leads us into what I'm calling an infinite software development loop. And the terms you've heard are CI/CD, DevSecOps, right? The terms go on: continuous integration, continuous development. Software development in the automotive industry is no longer a build once and deliver affair. It's just not. Whereas you built code, you put it into the vehicle, maybe updated it when there was a problem, maybe provided upgrades from time to time. The reality is that once the vehicle comes out of warranty, unless there is some recall, that software is not getting updated. Not the case anymore. And people are keeping their vehicles longer. Again, the code has become highly complex. You're looking at upwards of hundreds of millions of lines of code and multiple OSs that live within the vehicle itself. So when we talk about an edge computing platform, it now has to be able to juggle different operating systems, different applications, having them all talking to each other, communicating to the outside world. It is not easy. And so you get into one of these situations of what I call exaggerated, because anytime there's an issue with the deployment frequency of the code, or time to resolve problems, or change failures when you make a change, they become very exaggerated because it's not happening once when the vehicle's rolled out or maybe in an update. It's happening all the time. And if we want to monetize, we want to give people a better experience and make them safer, we're going to have to deal with this. And the only way we're going to deal with this is by implementing a true DevSecOps type methodology for developing code and implementing it very, very quickly and making sure that it's secure. It has to happen. So these transport specific applications are going to have very intense security, as I talked about earlier. If they don't, they're going to have to. The binaries will be huge, and you're just going to need tons more storage on these vehicles. You're going to need tons more processing capability. You're going to build in capabilities that are artificial intelligence, like intelligent video, to identify obstacles and avoid them. it's going to get complex. So you're going to need a full computer system running there. And as I mentioned earlier, cybersecurity is a critical concern. I'm going to say it again. I can't say it enough times coming from that background. It's just going to take one person hijacking some vehicles and running them off the road before it gets a really good focus. And it's coming. I know it's coming. It's going to happen. I hate to be Chicken Little, but I know that's coming right there. So the edge will be delivered, I believe, via an ecosystem. You have to deliver edge as an ecosystem. And that ecosystem has four primary components to it. There are other components, but these are the ones that I see right now. The first is the development component. You're going to have to put in place holistic, cloud-based CI/CD platforms that have very advanced collaborative capabilities so you can work across the globe with multiple teams. It's probably going to be a combination of on-premise cloud and off-premise cloud working together to deliver these very highly integrated applications and systems. So that is definitely a requirement. If you don't have a CI/CD environment, and I'm not saying most people do at this point, but if it's roll your own, you need to really look at that and ask how much more work is going to go into keeping that supported as you go further and further into a CI/CD world. The second part of the automotive edge that's important is around deployment. These systems that we put out there into the vehicles will be orchestrated onto bare metal. Applications will go into virtualized OSs, and we're going to be using containers, like containerization of applications like Kubernetes in mass scale. So we have to have a way of deploying software, orchestrating it. Right now, orchestration will be somewhat limited because we're talking within a vehicle. But as we start talking about vehicles talking to other vehicles, now there's a need to orchestrate applications and data across different vehicles. Each one of these vehicles becomes its own little cloud. So operation will be the third area. And as we build this connected world within the automotive industry, we're going to have to put in place global dashboards providing real-time insights with triggers and alerts and alarms and people that deal with that. We're going to be taking a large amount of intelligence coming in from the field and providing feedback on that and taking action very, very quickly. We're going to be looking at where the errors are, identifying what the critical path is to resolve those errors, and making that happen very fast in real time. I think that's going to be an area of great focus as time goes on. And then lastly, for the edge, optimization will be key. Those intelligent feedback loops I showed you earlier, the IFLs, are going to be continuously ingested. And what many companies have seen is that they produce a lot of data but never do anything with it. So that data coming in is going to have to be ingested continuously. I believe that AI-assisted observation of that data and crunching of that data is going to occur so we can do it in real time and get some type of effective use out of that data. So I think we're going to see a lot of that. And then by taking that data and bringing it in and optimizing our systems, we can really provide greater vehicle efficiency for people. We can give them better safety. We can improve the user experience, do a lot of really neat stuff. And again, that stuff can be monetized. So there's some good opportunities there, I think. So this is a very simple model, what we're talking about here. When we're looking at the automotive edge, this is what we have essentially. We have a live vehicle rolling down the road. That vehicle is going to have some type of what we call a cloud, for lack of better words. Think of this as the edge computing capability, things that can happen there very dynamically. And that vehicle is going to be generating data, intelligent feedback that's going to go back off into a cloud, back into a backend system. And we're going to have data coming down to that vehicle to perform system management, to update it, whatever. The customers themselves will also be interacting with the vehicle, both indirectly through web interfaces and applications to change settings on the vehicles, to look at performance data, and they'll be acting directly, say, to open up a lock on a door, right? That's something you see right now as a capability. So there's an indirect and direct vehicle communications. The vehicles themselves will be doing a lot of communication with other objects. So say a stoplight turns red, you now have the ability to notify the vehicle, alert the customer in the car, get them to put the brakes on or put the brake on for them, avoid a lot of accidents, loss of life. So this stuff is very interconnected. Now, the developers will also be tied in through this same interface into a web, and they as well will be going in and developing code and looking at the results of that code and seeing things in real time. You'll probably see a combination. We know that some automotive manufacturers are partial to keeping all their proprietary data on site. So we'll see on-premise cloud where they do that, keep all their code there safely. But we will also see off-premise cloud where we collaborate and where we allow consumers in. And there'll probably be some type of indirect synchronization between them. Firewalls everywhere to make sure that we actually keep things safe. And in this world, we will also have the ability to test hardware physically and virtually. We're working with customers right now to look at virtual hardware testing capabilities and digital twins to be able to really model these vehicles and test all these system changes before they even hit the road. And I'm not going to get into this in great detail here, this diagram, but I do have it up here. I want you to see it, is that at the heart of this, you need to have an edge platform. And it delivers those things I just talked about earlier, some of those attributes of an edge platform, primarily development, the ability to develop applications, operating systems, and things like that, the ability to deploy those things to the vehicles, the ability to operate everything, and then being able to provide supporting services to that edge platform. It's not really part of the edge platform per se, but there are services that are tied into that edge platform, third-party providers, different type of applications, et cetera. But the idea here is that it becomes very fluid, very interconnected, and it becomes a more continuous type experience versus being very disjointed where somebody develops code, sends it to the field, they put it in a vehicle, the vehicle goes through testing, that data comes back. It's not going to be occurring like that. It's going to be occurring real time. And changes are going to be happening real time. And that's what we need to be aware of in this space, that things are going to be changing like that very, very rapidly. I've also included, we can look at this, we don't have to go into this in great detail, but I've included this because I want everybody to see that there is architecture tied to this. When we begin looking at the cloud platforms themselves, the devices, where the development occurs, there is an architecture. It does integrate different components from third-party manufacturers, customer tools. We leverage our own technologies like VxWorks and Linux to deliver mission-critical real-time operating systems. So there's a lot of stuff that goes into it. We have Kubernetes containers, a lot of different pieces that come together to deliver this platform. And at the end of the day, we're aware of these, we plan for these, and we build a platform that can address all these different things for the different entities that have to interact with it. So my thing really, if I were just going to summarize this, I did up here at the top, is that by leveraging our existing tooling and combining it with third-party product suites, and then we wrap it with a fully integrated DevSecOps platform, Wind River is able to deliver the edge at speed. And that's important because delivering the edge in bits and pieces is not going to cut it. It has to be done at speed if we're going to be able to support our customers' real-time mission-critical requirements, which we know they will have and which we know they have right now. It will become even more exaggerated as time goes on. I'm going to check my questions again. Yes, and Ollie, you had asked a question about the Symix, like what we provide at Wind River. Yes, Symix would be an example of hardware emulation that we provide that would be integrated into this platform, as well as other things too. We know there are other hardware simulation platforms that we would need to include and incorporate here, and we're doing that with our customers right now. So thank you for that question. Something that's happening. So basically, one of the things I put out there for this presentation is who's going to own the edge. Now, I would love to say that our company will own the edge in its entirety. That's great. From a business proposition, it sounds great. I think that we will provide huge presence in edge computing. But I don't believe that we're going to own it in the entirety. Nobody's really going to own it in its entirety. You have people that are going to come together and work together to deliver solutions. But there are companies that are going to deliver and make edge computing a reality by providing a very robust, coherent platform. The automotive edge is going to require a very solid and validated ecosystem of partners. I've had this conversation over and over again. I don't care what use case we're talking about. whether it's 5G connectivity or robots or intelligent video, whatever it is, it doesn't matter. It's a partnership. And you're going to have companies that are going to come into this partnership and provide different capabilities. And we're going to have to make sure those capabilities work and that they seamlessly integrate to the solutions that we're putting out there for our customers. That's going to be pretty critical. But I do believe over time, as we create these solutions and blueprint them, it will get to a point where we can roll them very quickly. We know that they are part of our tool set, and we say, oh, we need intelligent video, great. We need this GPU, this piece of software, say from Chooch that does intelligent video. We need a cloud platform provided by Wind River, and we need to wrap that with Wind River Studio for a DevSecOps environment. Boom, and we deliver an intelligent video capability to the customer. Partnership, but it will happen. I think that the companies they'll buy for edge computing platforms. They're going to have to tie together those 4 attributes of intelligent auto edge that I showed you earlier. If you don't remember, you can go back and take a look at that. And the automotive edge has to be what I call skinny. And what I mean by that is that we have to drive maximum efficiency out of the minimum hardware and software to deliver value at scale. So we can't put big pigs of a computer in these cars and spend tons of money putting them in and then not have them return the value that we need to return. So whatever software is being implemented to deliver the edge, hardware and software combo, it has to be skinny. It has to be very lightweight and very efficient. That's something that we specialize in. That's why we're looking at different areas where we can bring our technology to bear, because we drive maximum efficiency there. And really, I think at the end of the day, the automotive edge has to be ultra reliable, right? It has to work like when you turn the ignition key or press the button to start the vehicle. It has to be very low latency. We can't have room for lags in there when safety and security are at stake. And then it has to be extensible as well. We have to be able to provide an edge computing environment that lets you plug in solutions from different partners, work with different middleware, et cetera. And then it has to be resilient. If you knock that vehicle against 10 trees, does the computer still work? So we have to make sure that hardware is resilient, and then the software that runs on it can make corrections if there is a hardware issue and reroute or redo. So it's all critical type stuff. So lastly, coming into monetization, I'm a big believer that you don't just do tech for the sake of doing tech. If there's no business reasons behind it, why bother, right? I mean, we're in here to make money at the end of the day and provide a service to our customers that they care about. I've put a few here. These are just some. I would say there are hundreds of monetization opportunities in the automotive edge. Here's a few. I'm just going to go through them kind of quickly. Hyper-personalization is a term that I'm going to steal it from marketing. Marketing has been generally using that to say that you work with a CRM and user buying habits to present to people things that are important to them that they would want to buy, right? But I think hyper-personalization in this concept is really the answer to unique out-of-the-box customer experiences. And I also think that there'll be an opportunity to sell customers in their vehicles on different applications that provide enhanced functionality, and also microtransactions. So in the gaming world, you're playing a video game and you want to change a character's skin. So for example, one of the characters that you play, you want them to have a red dress instead of a blue dress. You can pay $1 and get the red dress, right? Just in the case with a vehicle, you could pay $1 and change the lights to purple in the car instead of red. I'm just giving you an example. But the idea is to be able to personalize that experience and then be able to take that personalization and experience and make it follow them from vehicle to vehicle, from one brand to another. So there's some interesting stuff that could happen there, and it's all monetizable. We also know that there's insight-driven advertising coming from Verizon. I'm very aware of it. People don't really know this, that a lot of that information is tracked, right? They know where you go and what you're doing. And it's used to help provide you with advertising that is important to you, things that you care about. So there's an opportunity in the future. Car drives by a specific cafe every day. They drive by that cafe every day, and the user has opted in to give you that data and allows you to use that data. And you send them a coupon that shows up on their entertainment system that says, hey, save $1 when you drive by the cafe today. So that's insight-driven advertising, and I think that's a very important aspect here. Intelligent feedback, we've talked about this, the intelligent feedback loops. I think that paired with targeted marketing opportunities like we just talked about, you can capture new revenue streams and lead to a better overall customer experience. So the customer's happier and you make money. So some examples of that might be like a Safety Plus subscription. So if you could make that vehicle safer for somebody and they're willing to pay $5 extra a month to get additional safety, I don't know what it might be, but it could be different attributes of safety, right? Things that warn them or tell them to drive differently, and they're willing to pay for it or pay for it for their child, you now have a subscription. You're now making money every month. There are things like auto service retention. I told you earlier, I gave that example about the brakes going bad. They could go to their local mechanic and get their brakes fixed when they're already worn down to the rotor and there's no use anymore. They got to replace all the parts, or you can redirect them to the service center that they drive past every single day because you know that, and give them a coupon to go in there and get those brakes checks and get them fixed. Now you've retained more of that revenue back to the dealership, back to the parent company at the end of the day. You also have the ability to integrate third-party applications. So insurance companies that provide discounts for safe driving, they use dongles right now that attach to like the OBD port. You could use integration here and bring that in and be charging that insurance company every month for that access to the vehicle. Software-defined performance, I think, is another really cool area. As a gearhead myself, I love this. The ability to sell people performance enhancements that push the vehicles beyond their normal limits, but still be able to provide them warranted service, right? If something goes wrong, there's a big market for that. There are a lot of people that would probably pay money every single month to be able to test out different performance enhancements and be able to stay within their warranty. That's one of the big concerns when they're still in their warranty period. You can also probably get people to actually pay to be beta testers. It's a possibility, or you can compensate them in some other way or whatever. But there's also an opportunity to subscription analytics where somebody actually gets analytics about their driving, their vehicle, whatever, delivered to their phone. They could really like that. Could be a value add for the customer, or could something you charge them. And lastly, the edge computer licensing models have not even, I don't think they've been explored yet. When you start delivering these edge platforms within the vehicle, there are platform licensing fees that you will be passing through to companies that want to provide services. There's App Store revenue, just like Apple, just like Apple and Google make money off of their app stores. There is an opportunity to make money off of the applications built into the edge platform. And for example, Wind River right now, we have what we call a gallery, which is the capability to deliver applications like this to the edge. So that capability is already there, and it could be leveraged by vehicle manufacturers. And then you have an additional ability to do add-on services. So for example, AAA auto service, you could charge them a small monthly fee to be part of that vehicle, to know when there's a problem there, to know when there's a flat, or know the battery's dead, and send somebody out there proactively to jumpstart the battery before they even get there. So there's some really neat opportunities, I think, that are going to present themselves for monetization. So if people will ask me, they go, realistically, where do I start here if I want to go down this path? So I say start with a roadmap. Identify your required capabilities and specifications. We're doing this with a lot of customers right now. They're showing us their roadmaps, where they want to go. We're showing them ours, and then we're aligning those roadmaps somewhere in between. There are situations where the roadmaps are complementary, and there are other situations where they diverge. And we've got to figure out, well, do they diverge, or can we bring them together to provide a better customer experience, better monetization, et cetera? So we come out of that, these sessions with an understanding of what the capabilities are, where the gaps are, and then how do we partner? And then we adjust our roadmaps as required and move on to the next phase. Going out of that, we get into monetization, my favorite topic. We articulate the current revenue streams. We identify what the new streams look like, kind of what I was just showing you in the last slide. We model what this stuff costs to deliver to the customer and what we're going to make on it. What's the return on investment? And then we validate the financials. So we go into this with a very sound business plan. And then we do a limited proof of concept. We identify the highest impact, lowest risk capabilities that we can deliver to our customers. We document what it's going to take to deliver that stuff. We put metrics in place for success or failure to gate it. And then we implement that capability on a limited basis. And as we're moving again towards a more edge computing type environment in the vehicles, there will be a capability for us to deliver pilot programs. And we can look at them and see how they do. Is this a good idea? Yes or no? Pass it, fail it, move it on, or iterate again. And then lastly, the long-term deployment as this stuff becomes real and it's running all the time. We have to go through and document what the framework looks like. Implement the primary production components that are involved in it. Bring in the partners and integrate their applications as well. Perform, vast amounts of testing and validation of solution and validate certifications, things like that. And then deliver a minimum viable product, and then just drive iteration via those continuous feedback loops that we've talked about earlier. So that's kind of where we're going there. So hopefully you've enjoyed this today. I know it's a lot of area to cover, but I wanted to give you some things to think about, some places maybe where you'd like to dive deeper and explore. And I left some links here and we'll make sure we get these to you. But with my contact information, feel free to contact me, learn more about Wind River Studio, and learn more about what we're doing in the intelligent system space for automotive.
There are a few questions here that we can attempt to address. So the first one being, if you had to sum it up, what would you say are the key principles for the extreme edge for automotive?
If we're talking about extreme edge, I would have to say that it's something that has to be hardened. It's something that's possibly in motion. There's a lot of data being produced at that location and consumed and processed and acted upon at that location. It's an edge that lives within the final destination. So in this case, an automobile. If we were talking about edge in the medical world, it could be a device in their heart, right, sitting next to their heart. It's where that type of compute capability is required at speed. So that's kind of what I was thinking there.
Fantastic. And what are some of those key use cases? You highlighted quite a few within your presentation, but what do you think are going to be the ones that bubble up to the top in terms of the ones that automotive should look to tackle first?
I think that we're seeing this across multiple industries, what the most viable use cases are. I would probably say in the automotive space, we're going to see smart city integration. That's one of them. We're going to see a lot of 5G communication type use cases, vehicle to vehicle, vehicle to object, back to the carriers. We're also going to see probably a lot of robotics. There's a lot of capability being leveraged for edge in the robotics space. That's occurring right now. I think that robotics lend themselves to the vehicles themselves. And then there are like IVA, you have intelligent video and analytics, which is already being integrated into these vehicles right now. And it's very sophisticated. It's to the point now where these vehicles can recognize their owners coming and unlock the door for them and make sure all the kids are in the car and you didn't leave one standing at the corner at the grocery store. There's intelligence coming, so it's kind of neat.
Fantastic. So one of our listeners says, great presentation, and wants to understand what are your thoughts on how you can rapidly recertify these connected safety critical systems?
Yeah, I don't know if we're going to be able to do certification quickly. I don't equate those two words together. I think we're going to have to look for opportunities to integrate existing technology with newer technology and then be able to move at a pace that makes sense. I also believe that over time, the certifications will become, I'm not going to say lax, but they will encompass the whole software-defined world and edge compute world. And you'll have to make exceptions, right? You'll have to say that we have certain tolerances that we couldn't meet before, but now we have to accept those tolerances because we have the ability to process 10 times faster or whatever. There's some trade-off that's going to have to occur there. But I think we're going to have to look at each one of those on an individual basis and see what's required. Hopefully that answered the question.
All right, and then we're going to do one last question because we're almost at time. And for those questions that we don't get a chance to have answered, what we'll do is follow up direct with you because we do have your email from the registration page. So the last question here, Mike, says Tesla and Rivian are benefiting from the lack of complexity that accompanies being a new entry into the automotive landscape. How are they set up to manage and reduce the pain of the inevitable complexity?
Yeah, that was a great question. Thank you, Matt. I saw that. I think that Tesla and Rivian benefit, as you're saying here, from starting with a blank sheet of paper. They're able to develop a system from the ground up and then build the car on top of it, right? They don't have to go and reverse engineer. So yeah, it does. It helps them get around a lot of the complexity. But I have to say that eventually those vehicles will have to integrate with other vehicles. They'll have to integrate with smart cities. They're going to have to integrate with supply chains and maybe dealerships. I know Tesla isn't a dealership, but they'll maybe have to integrate with dealerships, with service centers, and that stuff's coming. Now, can I speak to how they're set up internally to deal with that? No, I can't right now. But I do believe they are going to have to deal with that pain at some point, Matt. I don't think they're going to get away with it, of not being able to do it. But again, they have the benefit of being an early entrant and designing from a blank sheet of paper. We'll see how it goes.
So thank you all for joining Wind River's presentation today. Mike, thank you for presenting. If you do have any additional questions or comments, definitely feel free to reach out to Wind River Sales, and we'll be more than happy to address any additional questions that you may have. But for those that didn't get addressed here today, we will follow up direct with you via email. So thank you. Thank you for your time and attention. With that,
thank you very much. All right, and thank you, Brandy, for hosting.
Thank you. Bye now.
Bye.